Today I have discussed on the introduction to computer organization. The computer is a digital device that can take the input from the user mode, processing the input, and at last the display the final output through the output device. These are the logical diagram of the computer system. There are 5 components are to be considered. First one is called the input unit. Using this unit, user can put the input to the computer system. Then the control unit, the control unit can control all over the operation of the computer system. Then ALU, the full form of ALU, arithmetic logic unit. Any kind of arithmetic and logical operation are to be conducted using this unit. And the next component, that is called the memory. During the execution, any intermediate data or information store, as well as the information which will be required in future, those information permanently stored in this component. And lastly, these are the output device. Using this device, the final outcome can be displayed for the user. So these are the basic diagram of the computer system. The computer system consists of the some internal device, some external device. The motherboard, processor, SMPS, those are the internal device, and the keyboard, mouse, printer, scanner, those are the output external device. The total system is composed by the internal as well as the external device, and those devices can be communicate each other and create a sophisticated device. Using this device, the user can be able to perform the tasks which will be required. According to the computer organization, these coordination and synchronization among the internal device as well as the external device, this synchronization process is called the computer organization. These are the example how the computer system perform the arithmetic operation. Using the input unit that can take the numeric value 15 and 7 with the help of the variable x and y. So those two information or basic data are to be sent to the unit, composite unit, that is called the central processing unit. This central processing unit can control the total operation. That means that take the input from the input mode, then the corresponding data are to be stored within the control unit. According to the arithmetic operation, here we conduct the addition. So these are the arithmetic operation. This arithmetic operation done by the arithmetic logic unit. So when the arithmetic logic unit realize that there have a addition, so based on this arithmetic operation, take the two operand 15 and 7 through the variable x and y and perform the arithmetic operation, and at last the resultant value that is stored the another variable z, and z value is displayed through the output unit. So in this way the basic arithmetic operation will be conducted. And these are the reference books. The generally we are follows the reference book, that is the computer organization, and the author T.K. Ghosh, that is the Tarun Kumar Ghosh. Thank you. Today we discuss the instruction set. Instruction define the basic operation of the computer system. A computer system have a collection of instruction. So the region or collection of instruction is called the instruction set. So the aspect of the instruction set, there are the number of aspects of the instruction set like flexibility of the programmer, number of addressing mode, number of general purpose registers, system performance and application. If a computer system support the varieties type of instruction, so the programmer can resolve a problem in different way. So this can be very helpful for the programmer if the system provided the different or varieties type of instruction. Second, the number of addressing mode. Addressing mode is the technique in which way the operand of the instruction is to be provided. If there are number of addressing mode are there, so the programmer can define as well as the system can have the flexibility to different way accessing the operand during the execution. Next one is the number of general purpose register. Register is the internal device. If there are number of register are there, that indicate that the intermediate data or the active data which will be frequently required during the whole execution are can be stored. If there are number of register are there, so the huge active portion or intermediate data can be stored within the register. Otherwise, those data can be stored within the memory. So the during the execution, those data are frequently accessed and memory related operation are increased. So this can be reduce the system performance. So indirectly, if we increase the general purpose register, that can improve the system performance. The system performance is the basic criteria when we developed an computer system. That means the execution, efficiency, performance all are depend upon the or criteria of the system. Okay, an application that means if there have number of opportunity are there, so those opportunities are can support the varieties type of solution. Okay, if the addressing mode is less, number of general purpose register is less, so the system can have a limitation. If a system support the varieties type of addressing mode, number of general purpose register, so the applicability of the system will be increased. So these are the aspect of the instruction set. Now the instruction format. The instruction format generally consists of the three parts. First is called the opcode, that is called the operation code. Second is mode, and last one is called the address. Opcode, that is the operation code. These portion define which operation are to be defined by this instruction. There are different type of operation are there: logical operation, arithmetic operation, shifting operation, branching operation, control operation. So the system can have some predefined opcode, and each and every opcode have a specific task. These are the opcode. Next, the mode. The mode means that is the addressing mode. When we execute any kind of arithmetic operation, logical operation or branching operation, we need the different type of operand. So those operand are stored either in memory or register or any other type of storage component. So how those operand are accessing from the storage component? So this accessing method is called the addressing mode. So which type of addressing mode are to be considered by this instruction? So this is defined by the mode, and at last the address of the operand. So the address may be register or cache memory, main memory, secondary memory or any other type of storage component or storage location. So those location are to be defined by the address. So these address are considered within the address part. So the instruction format generally three type of information or part are considered of code. This is the operation code, define the operation mode. This is the addressing mode, in which way the operand are to be fetched, and last the location of the operand, that is the address. The CPU organization. So the CPU can be considered which type of instruction are to be considered? There are the three type of CPU organization are to be considered. One is called the single accumulator based organization, general register based organization, and last one is called the stack based organization. In the single accumulator based organization, here the accumulator can be considered the location of the one operand, and another operand location can be considered any other type of storage component. In the general register purpose organization, here the operand are stored within the register. That means before the execution of the instruction, the operand stored within the register. After the execution, the resultant value also stored within the register. And stack based organization, here the operand and resultant value all are stored within the system defined stack. Here no register or memory are to be considered. A logical storage device, that is fast in fast out storage system, can be considered where the operand are to be stored. Okay. Then the length of the instruction. There are four type of instruction length can be considered: 3 address instruction, 2 address instruction, 1 address instruction, and 0 address instruction. The length of the instruction is defined or based on the number of address. Address means the address of the operand. Then the 3 address instruction, there are three operand are to be considered: 2 for the source address and another is the consider the destination address. The source address are hold the address of the 2 operand, and the destination address, here after the execution the resultant value will be stored. In here this is the opcode, and these are the 3 address R1, A and B. Opcode, this is the add, indicate the addition operation. These are the destination location, and these are the 2 memory location or memory address. That means the 2 operand define the location within the memory. Address is A, another location of the memory, that is address B, and after the execution the resultant value stored within general purpose register A. This is, there have 3 address. This is called the 3 address instruction. Similarly, this is the 2 address instruction. This is the opcode A. This is the destination location, and this is the source location, and the operation is defined like here. The destination operation R1 equal to R1 plus memory location A. So these are the 2 operand, and the operand R1 also modified after the execution. In the 3 address instruction, there have been no modification are to be done in the source address, but in the 2 address instruction the one source address R1 is modified after the execution. Similarly, the 1 address instruction, here this is the opcode and single address A, and another operand are to be considered the accumulator. That means 2 operand, one is held by the accumulator and another is the memory location A, and after the execution the resultant value will be stored in the accumulator AC. And 0 address instruction, there have no such kind of memory or other type of storage device are not considered. Here a system defined stack or logical storage concept is to be considered. Here the first in first out logic. So add, singly add without any address are defined. That means the pop the 2 topmost operand A and B of the stack and execute the operation. After that the resultant value also stored top of the stack. In this way, without any memory or other register or other memory location are not considered in the 0 address instruction. This is the advantage of the 0 address instruction. ব্যাস কোটা শেষ, কালকে দিয়ে দেবো। Today we discuss the topic memory organization. Memory is a very important component of the computer system. In this, using this component, we can store the data or information for the future purpose as well as during the execution. So any intermediate data that is stored within the memory. So during the execution, there have an interaction between the processor and memory. So the data can be stored within a memory as well as fetch the data from the memory which will be required during the execution. So the system performance is depend upon the communication between the memory and the processor. If the communication is very high, that means the accessing time of the data from the memory is low, so the execution time will be decreased. That means the performance of the computer system is depend upon the speed between the processor and memory. The memory can be considered the three parameter, that is called the capacity, speed, bandwidth or data transfer rate. Capacity, that is indicate how much amount of data or information stored within a memory component. So this is defined the capacity. The capacity can be defined with the help of the two parameter, the number of block of the memory and individual memory block can hold how much bit of information stored. So the capacity is depend upon the two connection. One is called the data connection and another is called the address connection. The data connection is indicate how much how many number of bit are stored within a particular block. So these are the indication of number of data connection, and the address connection, that is the depend upon the number of block present within the memory component. So in this way we can define the capacity of the memory component. And speed, these are the parameter, very useful parameter. These can be measure the how much amount of time required to fetch the data from the memory. If the less number of time required to fetch the data from the memory, that means the performance of the memory is high. If the accessing time is high, so the performance of the parameter memory is low. So in this way we can measure the performance of the memory component. And lastly, this is called the bandwidth or data transfer rate. In a particular time interval, how much amount of data will be moved from one memory to other component, alternatively to move the other component to the memory. So these are called the data transfer rate of the memory. And this is the memory hierarchy. That means the speed of the processor and speed of the memory are huge difference. So that means there are a huge gap between the processing speed of the processor and access time of the memory. So these gap can create a problem, that means that can reduce the performance of the computer system. If the speed gap of those two components is less, so the processor can easily access or quickly access the particular information which will be required during the execution from the memory quickly. So the communication time can be reduced. If the gap is high, that means the desired information which will be fetched from the memory require the much amount of time, so that can increase the execution time of the system. So these are the problem. This problem can be tried to resolve by the memory hierarchy. Memory hierarchy is the concept here that varieties type of memory component are to be introduced where the speed of the components are different and the cost also the different. The memory component which one is the high speed as well as the high cost. So if we consider the high speed memory component, that can create, but that can increase the manufacturing cost of the computer system. So this is the burden of the user. So these problem try to resolve by the memory hierarchy, where the different size, different speed and different data transfer rate are to be considered to create a such kind of system where the cost of the system will be reasonable, as well as the speed of the system also reasonable according to the user requirement. These are the structure these are the structure of the memory hierarchy. So the secondary memory, this is the low cost, high capacity, but the accessing time is very high, and these are the permanent storage device. And then the upper layer memory component, this is called the main memory. These are the volatile memory, and the speed of the main memory is much better than the secondary memory, and the cost of the main memory is higher than the secondary memory. After that, the cache memory, these are the very high speed memory component, and the capacity of the cache memory is comparatively very low, and these memory component can hold the active portion of the program which will be currently executed by the processor. And the lastly, these are the internal memory, that is called the register. This memory is directly attached to the processor. The frequently or active data part are stored within the internal storage device, that is called the register. So the register is directly connected to the processor. So the active, that means the generated or produce information or data at first stored within the register, and when any data will be required to the during the execution, so those information also stored within the register. That means the register, the speed of the register near equal to same to the processor. So in this way we can create a reasonable system where thus reduce the speed gap between the processor and memory. So these are the basic concept of the memory hierarchy. And lastly, these are the way how to accessing the memory. So there are the 4 type of accessing time. This is first one is called the sequential or serial access, second one is called the random access, third one is direct or semi-random access, and lastly this is called the associative access. Sequential access, these using this accessing method, the data or information can be searching from top to bottom according to the requirement, and when the desired location is reached, so this particular block of information will be accessed. These are the first method. Second method, this is the random access method. Here we are not follow the sequentially, randomly choose here and there when the desired location will be matched. So those particular block of information will be accessing. And third one is called the direct or semi-random access. Here the direct, the content of the block is used to accessing the data from the memory. According to the content of the memory block, the which location will be choose to store that data, that is depend upon the content of the content itself. So this is the most efficient and most usable memory access method. And lastly, this is called the associative mapping. So this type of mapping can be consider the content of the block and DGR information are match a special type of with the help of the special type of logic. So these are the another type of accessing method. This is also the some advantage and some disadvantage, because these type of memory access require the another logic and another hardware component. So these hardware component can have the external cost. So these are the way to accessing the method. Now we discuss about the main memory, that is also called random access memory, or shortly that is called RAM. RAM is the memory that can hold the active portion of the program, so the processor can directly access the main memory. The random access memory means during the execution the processor can generate the intermediate data and also the require any information that is stored within the main memory. So the processor can read operation as well as write operation can be executed randomly, any situation without any sequence, according to the programming chronological order, according to the execution or according to the execution of the programming functionality. The processor can access the memory as well as store the newly generated information or data within a memory. So randomly accessing the read operation as well as write operation, in this way this is called the random access memory. So these are the comparatively larger size of memory than the internal storage device as well as the cache memory. Then the type of the RAM, generally there are two type of RAM can be considered. One is called the SRAM, that is called the static RAM, another is called the dynamic RAM. The static RAM, that is this type of RAM can store the data statistically, whereas the dynamic RAM, these are the another type of RAM, the data are to be restored frequently. So in this way this is called the dynamic RAM. Both the RAM are to be considered to construct the main memory. The SRAM, this is the one type of RAM, and also the DRAM, this is another type of RAM. Both type of RAM can have some advantage, some disadvantage, and both type of RAM are to be considered to develop the main memory. Now we discuss the structure of the static RAM. Here the two type of connection can be considered. One is called the bit line, that is the data, and whereas another is called the word line, this is the address line. So the bit line provides the data that will be stored within the RAM cell. That these are the structure of one cell. So this particular cell can hold a single bit of information. So the information are to be passing by the two line B or B bar. If this information, this bit line hold the 0 information, so the complement information is held by the B bar. And what line, these are the address line. So this line is activated to read or write operation. Here in this structure they have a 4 component, 2 transistor, one, this is the transistor 1, this is the transistor 2. These 2 transistor consider just like a switch. When the watt line is high, so the transistor T1 as well as the transistor T2 is open, so the content of the bit line B bar is passing here to here. Similarly, the content of the bit line B are passing here to here during the write operation. When the bit information 0 or 1 is passing through the transistor T1, so at reach at the point 1, so these particular voltage or charge are provided to the NOT gate. So here if they have 0, so this 0 is provided through this NOT gate and there will be converted 1, and this 1 again flow this NOT gate, so 1 is converted 0, and these closed loop operation continue. So once if we put the any charge within this loop, so this charge will be rotated forever. So So these are the write operation. If we want to execute the read operation, at first the watt line is high, so this switch is open, this switch is open, so the content of this loop is passing through this transistor in the bit line B, and the complement information are passing to the transistor T2 and provided to the B bar. In this way we can store the data and read write operation are to be executed. Then the structure of the DRAM. So here the DRAM, there have only two components can be considered. One transistor, this transistor can be considered as a switch, and these are the capacitor. So the charge is held in this capacitor. The watt line, so when this watt line is high, so the transistor T is open, the content of the bit line are to be passing through this transistor and hold within the capacitor P. If this connection is open, that can, if this connection is open, that can be considered the 1. If this connection is closed, that means the charge that is passing through the transistor automatically grounded, there have no charge are there, that can be considered 0. So these are the structure of the dynamic RAM. These structure are called dynamic because the charge of the capacitor can be refreshed for a particular time interval. So in this way this is called the dynamic RAM. So here there are two components are there, whereas in the SRAM they have 4 components are there. So the size and cost of the DRAM is comparatively lower than the SRAM. Now here the comparison between the SRAM and DRAM. SRAM has the lower access time, which means it faster compared to the DRAM. That means the static RAM is faster than the DRAM. SRAM require the constant power supply, which means this type of memory consume more power, whereas DRAM offer reduced power consumption due to the fact that the information is stored in a capacitor. So the SRAM can consume more power, whereas DRAM can consume comparatively low power. Due to the relative small interval circuit in the 1-bit memory cell in the DRAM, the larger storage capacity in the single DRAM memory chip is available compared to the some physical size SRAM memory chip. In other words, the DRAM has high packaging density compared to the SRAM. The SRAM constructed with 4 components, whereas DRAM can be constructed with 2 components. So the density of the DRAM is much more higher than the SRAM, and SRAM is costlier than the DRAM because the SRAM can constructed the 4 components, whereas the DRAM can be constructed only 2 components. So the cost of the 4 component is obviously much more than the 2 component in the DRAM, 1 transistor and 1 capacitor, whereas the SRAM constructed 2 transistor as well as the 2 NOT gate. So the cost of the SRAM is higher than the DRAM. Okay, thank you.